Hi guys, how are you? Happy Pi Day. As usual, we will have pizza to celebrate the Pi Day. My son is now watching cartoons, I think. First, we will have a pizza together, and then I will be a little bit irrational today. See you in a bit. Bye. Happy Pi Day. Hi everybody, this is Arif. Happy Pi Day. Yes, today is the Pi Day of 2023. I celebrated with my family. We ate pizza and then later on we did some music together. It was so much fun. It's actually one of the holidays we celebrate each year. And we usually have pizza, okay? And now it is time to do something a little bit crazy. So this is how we will celebrate together, okay? So we have a trigonometric question, okay? We actually solved this problem, this question before in my channel. So I'll put a link under the descriptions. So you can go ahead and check. So it actually takes less than a minute to solve this, okay? But we will do something a little bit different today. I will solve this question by using analytical geometry. Analytical geometry.
Yeah. Well, that sounds very brave, like my name. I think it's going to be an overkill.
Hi, Bruce the Brave. I didn't know that you were here. Yes, this is going to be an overkill. Please take a seat and watch it. Welcome back, everybody. Now we will start to solve it. Okay, so we have three arctangent terms, right? So this one has 1, this one has 2, and this one has 3. So these are all positive, right? So what do we know about arctangent? So if this is positive, if the arguments are positive, these angles are all acute angles, right? So if we call this angle alpha, and this to be, let's say, phi, and this to be theta, okay? We know that alpha must be less than pi over 2, phi must be less than pi over 2, and theta must be less than pi over 2. So for each of these angles, I can actually draw a right triangle, right? So this is what I will do. Let's draw a coordinate system. So this is y, this is x, okay? So I'll first draw a triangle, right triangle for theta. So 1 unit here on the x-axis and 3 units like that. So this angle is 90 degrees, right? So I can simply connect this point and this point, making a right triangle here, okay? So let's call this point is O, this point is A, this point is B. This is good. So this is 1 unit here. So I'm going to pick another, I'm going to draw another right triangle for this guy here, for phi. So by the way, this angle is theta, right? So tangent theta is 3 over 1. This is good. So the base of this triangle, which I will define phi, okay, is going to be on the hypotenuse of this first triangle. So what I will draw here is a perpendicular to this guy. So this is my perpendicular. So this side will have length 1. And I'll call this point C. So I can simply connect this point. So this is D. So the distance between D and C is just 2. So this angle can be defined as phi. This is good. So I will do the exact same thing for the last triangle. So from here to here, so this will be the base. This is perpendicular. This is 1 unit. This is 1 unit. So I picked a base for the third triangle, which has 1 unit. And this side is also 1 unit. So I will connect that. So I have 3 right triangles oriented like this. So this point I will call it E, and the last point would be F. Okay? And this angle is, of course, now is alpha. So as you see, theta plus phi plus alpha can be actually calculated by using the coordinates of this last point f. And this is going to be our goal. So we'll try to find the coordinates of this point f. So if you are ready, we are starting. So welcome back everybody. I hope you're all clear with this geometry. So our goal is to find alpha plus phi plus theta, and the angles are defined as such. Okay, so we have three right triangles. This is good. So let's start with point A. So the point A has coordinates 1 and 0, right? This is easy. It's on the x-axis. So the point B will have coordinates 1 and 3. Okay. Good. So first of all, let's find the coordinates of C, x and y coordinates of C. So C is on the OB line, right? So if I say OB line segment, okay, this is the origin. So the points on the OB line are going to satisfy. So y is equal to 3x. That's it. Why? Because the slope is 3 over 1, which is 3. This is good. And this line passes through the origin. So when x is equal to 0, y must be equal to 0. Okay, so if I look at point C, so point C, so y of C must be equal to 3xc. So this is the first equation I have for the coordinates of C. What else do I know about point C? So it has to be at a distance of 1 from the origin. So we know that xc squared plus yc squared must be equal to 1. Okay, so if I know this, then this gives me 10, so this is xc squared plus yc is 3xc, so 9 plus 1 is equal to 10. So 10xc squared is equal to 1, so x of c must be equal to 1 over square root 10, and y of c must be equal to 3 over square root 10. So I found the coordinates of C. Now we will move on to point D. So far we have found the coordinates of A, B, and the point C. So the next step is to find the coordinates of D. Before that, let's look at the DC line segment. So we know that DC is perpendicular to OB, right? So since OB, the slope of OB is 3, okay? So the slope of DC times the slope of OB, which is 3, must be equal to minus 1 because they are perpendicular to each other. So the slope of the DC line segment must be equal to minus 1 over 3. So the line equation would be equal to minus 1 over 3 x plus b. So b is not 0 because the origin is not included here, right? So how can I solve for b? Well, I already know that c must be on this line, right? So if I use the coordinates of c, so 3 over square root of 10 must be equal to minus 1 over 3, 1 over square root of 10 plus b. Okay, so if I multiply this with 3, this becomes 9, right? If I put this one on this side, this becomes plus, right? But this becomes equal, right? So 9 plus 1, so they have the same denominator, right? So this just becomes 10. But 10 over square root 10 is simply equal to square root of 10 divided by 3 is equal to b. So we simply solve for the line equation for the DC. Okay? So all the points on the DC line segment should satisfy this equation. In the last board, I found a line equation which is satisfied by all the points on the DC line segment. And since the point D is on this line, its coordinates also satisfy that. So what else do I know about D? Well, D, look at C. So the distance between D and C is 2 units. Okay, this is a really good piece of information. So I know that xd minus xc square plus y of d, y of c square must be equal to 4, right? 2 square is equal to 4. So x of d minus, what is x of c? 1 over square root of 10 square plus, so what is y of d? It is square root of 10 over 3 minus xd over 3, right? And then minus y of c. Y of c is 3 over square root of 10. Square must be equal to 4. Okay, this is good. So I want to take 1/3 out here. Okay, so if I take 1/3 out, what happens is, so I simply multiply these terms by 3, right? So this becomes 9 here. So this will come out as 1 over 9. Okay, so 1/3 square is equal to 1 over 9. Okay, so I can multiply everything with 9. So this becomes 9 here, and this becomes 36. Okay, very good. So this term has 1 here. So if I multiply square root of 10 here, both the numerator and the denominator, I'll have 10 over square root of 10. So what is 10 over square root of 10 minus 9 over square root of 10? It is just 1 over square root of 10, right? So this square, here it was 36, right? So what do I see here? xd minus 1 over square root of 10 square plus 1 over square root of 10 minus xd square is equal to 36. So basically this and that are going to be equal, right? Because we are squaring that. So basically what we have is 10 xd minus 1 over square root of 10 square is equal to 36. So at this point I can take the square root of both sides. So this becomes square root of 10, this becomes 6, right? And here I'll have the absolute value of that. Okay, so we had 10 square of this term was equal to 36. So when I square both sides, I got square root of 10 here, absolute value of this term, and 6 here. And then I divided everything by square root of 10. Okay, at this point, I will have two roots, right? So this may come out as positive. So xd minus 1 over square root of 10 may be equal to 6 over square root of 10. So this gives me xd is equal to 7 over square root of 10, or this is nothing but 7 times square root of 10 over 10. Okay, so square root of 10 is something larger than 3, so 3 times 7 is 21, divided by 10 is like something like 2.1, so this is going to be something larger than 2. But we already know that the x-coordinate of d cannot be larger than 2, right? So this is not the possible answer for x of d. Okay, so this should come out as negative. So the absolute value, the term inside must be negative, right? So this is minus xd, okay? Then plus 1 over square root of 10 must be equal to 6 over square root of 10. Okay? So then this gives me x of d as, so 6 minus 1 is 5. X of d will be equal to minus 5 over square root of 10, or it's going to be minus 5 square root of 10 over 10, or minus square root of 10 over 2. Okay, minus 10 square root of minus square root of 10 over 2. So now it's time to find y of d. So if I put minus, so this is 10 square root of 3, square root of 10 plus over 3, plus here I have x minus square root of 10 over 2, right? So So this becomes positive, positive. So this is nothing but 6 over 6. So if I multiply this by 2, it becomes 2. Okay, so 2 plus 1 is 3. So this is gone. So 3 over 6 is equal to, so 3 over 6, I have 2 here. So y of d turns out to be square root of 10 over 2. So x of d is minus square root of 10 over 2. Y of d is equal to square root of 10 over 2. This is good. So we will move on from here. So in the last board, I found the coordinates of d. So if I look at the DO line segment here, okay, the slope of this guy here is nothing but the y coordinate of d divided by the x coordinate, right? Because the origin is included here. So the slope of the DO line segment would be equal to minus 1. Okay? So y is equal to minus x is nothing but the line equation of DO, right? This is good. So at this point, I actually know the answer here. Okay? Answer to this question. So please write in the comments how I can know the answer to this question. Okay? Right at this point. But as I promised you, I'll go ahead and solve for the coordinates of E and also for the coordinates of F. Okay? So let's move on. So y is equal to minus x is the line equation for DO. Okay, so I need to find the coordinates of E. So y of E is going to be equal to minus x of E. But I also know that point E is at a distance of 1 from the origin. So xe squared plus ye squared must be equal to 1. So ye is equal to minus xe, so this gives me 2xe squared is equal to 1. So x of E must be equal to minus 1 over square root 2, because the x coordinate of E must be negative. So the y coordinate is going to be positive. So ye is equal to 1 over square root of 2. So it was easy. So the next step is to find the coordinates of F. Okay, everybody, we are getting close to the final answer. So far we have found the coordinates of point E. So the x coordinate turned out to be minus 1 over square root of 2, and the y coordinate turned out to be 1 over square root of 2. So now the next step is to find the coordinates of F. So if I look at the line segment FE, it is actually perpendicular to the DO line segment. So the slope of DO was minus 1. So the slope of FE must be 1. So for the FE line segment, I can write y is equal to x plus b, because the slope is going to be 1, right? So b is not equal to 0 here because the origin is not on this line segment, right? So how can I find b? Well, I know the point E is on this line segment. So I can use its coordinates plus b, okay? Y and x coordinates of point E. So this gives me that b is going to be equal to 2 over square root of 2, which is equal to square root of 2. This is good. So instead of b, I can simply write square root of 2 here. And I know that point F is on this line segment. So I can write y of f is equal to xf plus square root of 2. What else do I know about f? Well, the distance between f and E must be equal to 1, right? So I can simply write xf minus xe square plus yf minus ye square must be equal to 1. Okay? So I know that xe is equal to minus 1 over square root of 2. So I can simply write it here. This becomes plus 1 over square root of 2. Y of f is given as xf plus square root of 2. So I can simply write it here. xf plus square root of 2. And ye is equal to 1 over square root of 2 here. So this is minus 1 over square root of 2 square is equal to 1. So if I multiply this term with 2, this gives me 2 square root of 2 and divide by 2. This gives me that. If I multiply this with square root of 2, this gives me square root 2 over 2. So in the end, 2 square root 2 minus square root 2 is equal to square root 2 over 2, right? But square root 2 over 2 is nothing but 1 over square root 2, right? Good. So basically these are the same, right? So I will have 2 xf plus 1 over square root 2 square is simply equal to 1. So I divide by 2 both sides, so this becomes 1 over 2, right? Then if I take the square root root of both sides, this gives me the absolute value here, right? This is good. So I have, as usual, two options here. So this may come out as positive. So we can say xf plus 1 over square root 2 is equal to 1 over square root 2. So this gives me xf is equal to 0. This is the first option. The second option is minus xf minus 1 over square root 2 is equal to 1 over square root 2. So if this is the case, xf turns out to be, so 2 over square root 2, which is equal to square root 2, and there's a minus sign here, minus square root 2, right? xf turns out to be like that. So as you see from this geometry, xf cannot be 0, right? The x-coordinate of f cannot be 0. So this is not the solution we are looking for. So xf must be equal to minus square root 2. So if I put xf here as minus square root 2, yf turns out to be 0, right? So what does this tell me? So this point f is actually on the x-axis. Okay, has to be on the x-axis. So if I correct this geometry, so what I see here is this. So this is my alpha. So point F must be here. Okay. Okay. So now we are ready to tell what arctangent 1 plus arctangent 2 plus arctangent 3 is. Okay. So alpha plus phi plus theta. Alpha plus phi plus theta. So this is equal to pi. And happy Pi Day. See you later, guys. Bye.